Okay, this is lesson 1.1, part 2. So we have the slope-intercept form of an equation. So slope-intercept form is when we have a line in y equals mx plus b form where m is the slope and b is the y-intercept. So notice the coordinate of the y-intercept will always be 0, b. And this is because the y-intercept is on the y-axis and x always equals 0 on the y-axis. So on this one, we need to solve for y if necessary, which in this case we don't. Identify the slope and the y-intercept. So in this case, the slope is the number in front of x, so it'll be 2/3. I'm going to write better in just a minute. This page just won't be good. So I'm just going to put a line under here. There's our slope. 1 is our y-intercept. And so next we plot the y-intercept, which will be at 1. Then we use the slope from that point to find our next point. So at 1, we go up 2/3, and then we will have a line through those 2 points. Oops, not perfect, but you get the idea, okay? Notice when we have f of x, it's really the same as writing y. It's just a different way of writing it. And it's saying that x is the input, f of x is the output. So don't be confused with that. It's just a different way of saying y. Okay, let's graph a couple more of these. So we have f of x equals 2x plus 4. So we can see this is in y equals mx plus b form. For this one, the slope will be 2. Now notice the slope is rise over run, and so we need a number it can run. So we'll just put it over 1 because that doesn't change the value, but that does give us a number we can use on the bottom. Our y-intercept is 4, and if you remember, at our y-intercept, x always equals 0. So it's really 0, 4. Okay, now we have our slope and y-intercept. We can graph this point. So we're at 0, 4. And then from that point, we use our slope to get to another point. So we can go up 2/1. Notice I'm going positive in both directions. Now, sometimes when you're graphing, especially on the computer, it might go off your graph. So what you could also do is you could go down 2, left 1. Now let's see, why does that work? Well, if we think of it as -2/-1, well, a negative divided by negative is still a positive. So that's still equal to +2/+1, as long as you're going down and left. So you're going negative in both directions. That's a little trick you can use to keep yourself on the screen. Oh, I was going to try to do this earlier, but it's not going to work. Okay, so we'll just do a terrible line through this. You can imagine, though, what it should look like. Okay, let's do this one. Example 11. So we have slope is -1/2. Y-intercept is 3. What would the ordered pair be for that one? Well, it should be 0, 3, because again, x always equals 0 at the y-intercept. Okay, now we go graph that y-intercept. So 1, 2, 3, graph that point. Now this slope, it's -1/2. So in this one, we only want to go -1 direction. So I'm going to go down 1, but then right 2. That's a positive direction. Again, if it was going off the graph, I could go the opposite. I could go up 1, but left 2, because that's only -1 direction. So that would be equivalent to 1/-2, which is equivalent. So something I want you to notice is if you look at the slope, this line does have a negative slope. If you look at this line, example 10, we have a positive slope, and it should have a positive slope. So that's one way you can check yourself, is if you do have a negative slope, make sure your graph reflects a negative slope. So horizontal lines have the form y equals b, where b is some real number. Okay, so it could be like y equals 2, but just any real number. The graph is parallel to the x-axis. So let's look at that. If we have a horizontal line, it's got to be parallel to the x-axis, which is right here. So for example, actually we'll look at this one graphed, y equals -3. You can see it's parallel to the x-axis, okay? So this is the line y equals -3. You could also look at it in a chart as shown here. No matter what x equals 0 or -2 or 4, y will always equal -3. And so that can help you plot a few points if it's hard to remember that it should be a horizontal line. So if we graphed y equals 5, 1, 2, 3, 4, 5. So it's just a line through where y equals 5. Again, you could make an xy chart and just see that y will always equal 5 no matter what the x value is. Vertical lines are similar, so they have the form x equals a. So they are parallel to the y-axis. So for example, if I had x equals 2, actually we'll look at a graph of this, or a chart. So no matter what x equals, or no matter what y equals, so -2, -1, 0. Well, if y equals -2, x is still 2. If y equals -1, x is still 2. If y is 0, x is still 2. So no matter what, x equals 2. You can see if we plot those points, we have a point here, a point here, a point here. So we can see this is just a vertical line through where x equals 2, and that also it is parallel to the y-axis. Example 18, we need to graph 2x plus 1 equals -3. So we would subtract 1 on both sides. We want to solve for x because it's the only variable. So we subtract 1, those cancel, so I get 2x equals -3 minus 1, or -4. Divide by 2 on both sides, and so x equals a -2. So let's think, how would that be graphed? Well, if that was confusing, I could make an xy chart and say, okay, let's say y is 2, 1, and 0. Well, no matter what y is, x will still be -2. X is always -2. So I can plot those points. We have -2, 2, -2, 1, -2, 0. We can see that will be a vertical line through where x equals -2 for our final answer. And notice it is parallel to that y-axis. Okay, let's look at some other equations. The first equation is another linear equation. This one can almost look tricky, but if you look at it in terms of y equals mx plus b, well, in this case, I could say it's f of x equals x plus 0, right? That doesn't change the value. And I could even put a 1 in front of the x. And so I can see here, well, my slope is just 1, or 1 over 1. Okay, my y-intercept is 0. Or since we know x also equals 0 at the y-intercept, it would just be the point 0, 0. And so we graph that, we're at 0, up 1 over 1, and then there's our line. Okay, absolute value. This parent function, let's just look at a little chart. Okay, so x is -2. And so we will substitute that in. Absolute value of -2 is just 2. Remember, absolute value is just saying what is this number's distance from 0. So it always will come out positive. Absolute value of -1 is just 1. Absolute value of 0 is just 0. Absolute value of 1, still positive because that distance from 1 is still just 1. Absolute value of 2 is 2. So we can see it looks like it's symmetrical, right? We have numbers repeating. So we have okay. So at -2, we're at 2, -1, 1, 0, 0, 1, 1, -2, 2. I think I said the negative in the wrong spot, but there we go. So that's what the parent function, so basically the basic absolute value graph, this is what it looks like. Okay, x squared, I'm going to leave that one for you to plug in. I would recommend plugging in those same points, -2, -1, 0, 1, 2. And you should get actually really similar to the last one. These points will be the same, but this one, instead of being a sharp vertex, is just a curved, okay? So quadratic, and then similarly with cubic, we'll have something like that, okay? but I'll leave it to you to plug in those points and see. But it's important. These are parent graphs that I would recommend knowing. You might even want to print them on cards just to remember what the basic function looks like when it's graphed.